taking a look at example number 1, we're going back to the problem that we first discussed a few weeks ago with Riemann sums. We were interested in calculating or approximating the calculation of the area between the function x squared and the x-axis from x equals 0 to x equals 2. And we did this through a left sum and a right sum. I believe we used 4 equal subintervals. And when we did so, I believe the left sum came out to 1.75 and the right sum was like 3.75. And we knew that neither of those were correct. They weren't exact, but they were a starting point. Because it was a Riemann sum and there were only 4 subintervals, it wasn't going to be super duper close, but it was somewhere to give us an approximation. Now that we have the fundamental theorem of calculus, now let's calculate this definite integral. And let's find out what the exact answer actually is. Okay, so what are our steps? First thing that we're going to do, we're going to take the antiderivative. Okay, because we need to go from, we're thinking of this as x squared as our derivative, we need to get to the original function. So we have to take the antiderivative, hence all the practice that we just did. So with x squared, it antiderives, we add 1 to the exponent, and then divide by that new exponent as well. 2 becomes 3. So we are going to have x cubed over 3. That's our antiderivative. Now this symbol is telling us to take the antiderivative. So now that we've taken the antiderivative, we're not going to have that symbol there anymore. Okay, but we still have to take into account the 0 and the 2. So what do? We're going to make a little mark afterwards. Some people do just a vertical line. Others will do a bracket like so. And we want to have the 0 and the 2 still represented. So we know that we have to plug those values in. The a value goes in the bottom and the b value up top, just as they were before. Okay. Now that we've taken the antiderivative, it's time to plug in our bounds. We plug in the b value first, followed by the a value. So the b value is 2. So this is going to be equal to 2 cubed over 3 minus, now we do f of a, 0 cubed over 3. And again, the whole idea behind this is the fundamental theorem of calculus that you see in that 5th bullet point or 6th bullet point right above this problem. Okay, which is doing f of b minus f of a, where this was f prime. Okay, well, 2 cubed is 8, 0 cubed is 0, so we end up having 8 over 3, or 2 and 0.6 repeating, 2 1/3. We can see that that is the exact value. It's pretty close to right in between our two sums, which we knew were just approximations, but that is the exact answer. And that's the power of the definite integral in the fundamental theorem of calculus.